Okay, we're going to be talking about this document. Okay. So, the first thing you do is you do any cancellations you can within any fractions. So, 35/60ths can be reduced. They both divide by 5, so this leaves me 7/12. Also, these x's, we're going to have some cancellations as well within the fraction. When you divide, you subtract the involved exponents. So this will cancel completely, and this will cut down to x to the 6 because 8 minus 2 leaves 6. Okay, now I think I'm going to, having finished to simplify the first fraction, I think what I'm going to do next is rewrite it more cleanly. Going to leave lots of space here to help me reduce my clutter, because these can get really cluttered. Okay, so 12 and 3, I can cancel those diagonally by dividing by 3. So 3 divided by 3 is 1, 12 divided by 3 is 4. For my x's, I can cancel these two by dividing, treating it like division. So this has the higher power, so this will cancel completely, and 10 take away 6 will leave 4, because you subtract exponents when you divide. So 10 take away 6 would leave 4. Also, these y's are going to cancel. 5 and 1. So this is going to cancel, and this is going to go down a power to 4. And for my z's, the z square will cancel entirely, and 9 take away 2 will leave 7. Okay, so I will have 7 x to the 4th over 32 y to the 4th z to the 7th. Okay, so that is the monomial. Here's monomial addition or multiplication. Here will be the monomial division. So let's see what happens when I move this. Okay, leaves me some more space. Okay, so I'm going to have example 2, 4 over 9xy to the 12th plus 11 over 10 x cubed y to the 4th z. All right, looks like I better unplug the computer. I'm liable to fall. Okay, now the LCD is got to be the lowest number. That 9 and 10 divide evenly, so that's 90. And if you're going to take all variables that appear, so that'd be x, that'd be y, and that'd be z, and you'll take the highest appearing power. That's different from greatest common factor, where you take only what appears in everything. Each term, exclusive to you, it has to appear in all terms, and you take the lowest appearing power. In least common multiple, or least common denominator, you're inclusive. So you'll take every variable that has any appearance at all in the denominators, and you'll take the higher appearing power. So between 1 and 3, 3. Between 12 and 4, 12. And you're going to keep the z as is. So we're going to have, so now what we need to do is convert. So we're going to have 4 over 9xy to the 12th times, we don't know, but we know that we're going for a fraction of 90 x cubed y to the 12th z. Okay? To get from 9 to 90, we need to multiply by 10. To get from x to x cubed, we need to multiply by x squared. And to get from no z to a z, we need to multiply by z. Now, if I multiply the bottom by that, I need to multiply the top by it. Oh, I forgot the problem has z to the fifth. Okay? I didn't copy my own work right, it looks like. So I would take z, so I'm going to rewind that. Okay? We're going to start over. So the LCD of this problem, because you need that for addition, least common multiple is in between 9 and 10 is 90. Between x cubed and x is x, you got y, and you got z. You're going to take all the variables that appear, period. You're going to take the higher appearing power for the LCD. So between 1 and 3, we take 3. Between 12 and 4, we take 12. And between no z at all and z to the fifth, we take a z to the fifth. Okay, so now we need to convert them. So 4 over 9x squared, or 9xy to the 12th, times, we don't know that part, but we know when it's over, we're going to want a fraction that's over 90, x cubed, y to the 12th, z. So to multiply 9 and get 9, to multiply 9 by something and get 90, we'll need to multiply by 10. To get from x to x cubed, we're going to need to multiply it by x squared. The y's don't need anything, but to get to z to the fifth, we're also going to need to multiply by z to the fifth. We're going to do it to the top as well. Okay? So that will give me 40, x squared, z to the fifth. Okay, we're going to do the same thing to the other one. 11 over 10 times, 11 over 10 x cubed, y to the fourth, z to the fifth, times, and it's going to need to be a fraction of 40 x squared, the LCD, which is 90 x cubed, y to 12th, z to the fifth. Does it all fit on the screen? Yes, it does. Okay. So to get from 10 to 90, we need to multiply by 9. To get from x cubed to x cubed, we don't need to do anything. To get from y to the fourth to y to the 12th, we need to multiply by y to the 8th. And to get from z to the fifth to z to the fifth, we don't need to do anything. So 9y to the 8th, multiply these, we get 99y to the 8th. Okay, so we're going to be adding these. Okay, so 40 x squared. So anytime you add fractions and we're adding these, you simply add the numerators over the common denominator. So 40x squared, z to the fifth, over the LCD, plus 99 y to the 8th over the LCD is simply going to give me these two plus each other, over my LCD, which is 90 x cubed, y to the 12th, z to the 5th. Okay, so that takes care of topic number 1. Okay, I'm going to modify the examples that are on the paper, and I'm going to add to them, okay? I'm going to start with this one. The LCD of monomials, denominators, is all the variables that appear in denominators. So here's a denominator, and there's a denominator. So we have to include x and y. We take the highest appearing. So for x to the fourth, for the x's, it's x to the fourth. For the y's, it's y to the fifth. Now, the next thing you do is multiply everything by your LCD. So 3 over x to the fourth times x to the fourth, y to the fifth, plus 1 over y to the fifth times x to the fourth, y to the fifth. And that includes anything that isn't a fraction as well. X to the fourth, y to the fifth. Over 1 over x cubed, y cubed, x to the fourth, y to the fifth. And then what you're going to do is you're going to cancel away your denominators. So x to the fourth divided by x to the fourth cancels completely. Y to the fifth divided by y to the fifth would cancel. Nothing cancels there. X to the fourth divided by x cubed would just leave me x to the first. And y to the fifth divided by y cubed would leave me y squared. So the end result is just simply 3y to the fifth plus x to the fourth minus 8x to the fourth, y to the fifth, over x, y squared, because x to the first is just x. All right, I'm going to pause here and put the next problem on the board. Okay, so here's another example. I decided not to do example 2 as is on the handout. I decided instead to dump the integer part. Okay, since you're more likely to face a problem like this instead of the other one that you saw. So the LCD between these two binomials is simply their product. So I will now proceed to multiply everything by the LCD. So, the fractions times these two by the LCD and these two by the LCD. All right, so I will now cancel away the denominators. So get rid of those, get rid of that, get rid of that, and get rid of this. And the result is 3 times x minus 2 plus 7x, x plus 5, over 2x times x minus 2 minus 6 times x plus 5. So this will be 3x minus 6 plus 7x squared plus 35x over 2x squared minus 4x minus 6x minus 30. Okay? I'm going to simplify these and put them in descending order. So that's going to be 7x squared plus 38x minus 6 over 2x squared minus 10x minus 30. And since this is factorable, I will. And that's it. I'm done with example 2. A. I'm going to put two additional, I'm going to be doing additional examples, okay, after I pause this and resume. Okay. So here's one that is non the paper. This is the only fraction within the fraction. Okay, remember complex fractions are fractions within fractions. This is the only fraction within a larger fraction. So it's the only denominator is x minus 15. So that's the LCD of the whole thing. So I will take x minus 15 times this, 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 and this. Like so. So I'll have x times x minus 15 plus 6 times x minus 15. So the only cancellation to be done is this, and I will have 13 plus 4x minus 60 over x squared minus 15x plus 6x minus 90. And this simplifies as, in descending order, 4x minus 47. And down here, I'll have x squared minus 9x minus 90. There's no pair of factors in -9.5 to -9, so I'm finished. Okay? Let me set up another one. Okay, here's another one. These are meant to be lowercase c's. So, the only fractions within the fraction are these two. They got c, and remember you take the highest appearing power. So c squared. So we'll take everything times c squared. Try to make it clear what's the parentheses and the c's. Like so. Okay. Now, there's nothing to do here. The c squared divided by c is just c the first. And the c squareds here cancel. That leaves me 130c squared minus 110c over 169c squared minus 121. And both of these factor. Okay? These two have a c in them, and they're both divisible by 10. So that 130 c squared divided by 10c is 13c. Minus 110c divided by 10c is minus 11. Down here, that's a difference of squares. This is 13c squared minus 11 squared. So I'll have 13c plus 11, 13c minus 11. And the 13c's cancel. The 13c minus 11's cancel, leaving me just 10c over 13c plus 11.